In this video, I will go over the homework that follows the lecture on the alternating series test. And as always, I hope that you watched the lecture. And let's jump right into the homework. And the first question is asking for which values of p the series diverges. And we need to recall the alternating series test. The alternating series test says that if you have a alternating series that without the alternating coefficient, the alternating sign coefficient is decreasing and converges to 0, then the series converges. So it's pretty much like a divergence test. So the setup is the same, but the conclusion is different. So anyway, let's figure this one out. So we have ln raised to the power p, and we're going to set up the alternating series test by setting up this limit as n goes to infinity. We're going to take the ln of 6n plus 5 raised to the power p, and we need to find out when is this equal to 0, because that's when we will conclude that the series converges, and otherwise it will diverge. So let's make this analysis here. So we have infinity raised to the power p, and if p is positive, then this will be equal to infinity. If p is negative, then this will be equal to 0. So the series will be converging when p is less than 0 and diverging, according to the alternating series test, when p is greater than 0. So the answer here is that p must be greater than 0. But at the same time, when p is greater than so when it's not equal to 0, then it's like the divergence test. So those two are closely related when it comes to alternating series. All right, next question. So we have a series given to us as a pattern. So the first thing we have to recognize is the pattern. And the pattern here is we're going to start at 1. And the first element is negative, so it's going to be -1 to the power n. And then we have 1 over 2 to the power, and I want to say n, which seems to be the case. And now this is a alternating series test. This is an alternating series, and to run the alternating series test, we're going to set up the limit of the nth term without the alternating sign. And to do that, we have to check a few conditions. We have to make sure that it is positive and it is decreasing. And both conditions are satisfied here, and we can see that that limit is equal to 0, and therefore this series converges. It converges by the alternating series test. All right, another series. So I will just write this alternating sign here. And we're going to use the alternating series test. And before we do that, we're going to check two conditions. First one, that what's left after you remove the alternating sign is positive, checked, and it's decreasing. This is where we may have some issues. It may not be decreasing, but we need that for convergence. So if it's not going to 0, then it's going to diverge for, well, A, the alternating series test cannot be applied, and B, it will be diverging by the divergence test. So again, those two are related closely in this case. So we're going to take the limit of the nth term, and we're going to learn that the limit is equal to 1/6, which is not equal to 0. So regardless of whether it's going down or not, we're not doing the alternating series test here. We're actually utilizing the divergence test. So this series diverges by the divergence test. And it's interesting how Newton actually kind of captures this logic in the way they make it the assignment. It used not to be the case. And I'm pretty sure it's not the case for some of the textbooks still. So good job, Newton. 4. Have another alternating series. Again, I'll write the alternating sign term here. And technically, the coefficient can be written out completely. So this series is exactly the same as this series. Notice how I cannot take the alternating term out because it has n in it. But I can take 3/11 out. And what we have left is just the p series. So, of course, let's see, if alternating series test is applicable, then it will be under two conditions. One is that it's positive, 2 that it's decreasing. Of course, it's going to be decreasing when p is positive. So the idea is that we're looking for this limit, and this limit is equal to 0 when p is positive, and it's equal to infinity when p is negative. And when p is positive, the series will converge. When p is negative, the series will diverge. And the question here is for which values of p it's converging, and it's converging when p is greater than 0. And that's it on this homework. If you have any questions, please let me know.